Hello, this is the next video, the texture aliasing, anti-aliasing video for INB382. So on this we are exploring some of the stronger effects that occur in this demo when you play around with the texture sampling parameters. So firing it up, you'll see the demo is a simple checkerboard on a quad. This is very common in computer graphics. The reason that this is used as a demo is because for texture sampling, due to the projection and the the angle of the quad with reference to the camera, projected pixels at the horizon over here are going to be strongly distorted. And that means that if you want to see whether your anti-aliasing algorithm works well, then you use a checkerboard like this because it's got lots of high frequencies and a strongly distorted sort of set of pixels at the horizon. And this is very similar to what you'll see if you've got a terrain with some sort of high frequency loaded texture. Then if you've got problems with your aliasing, it'll occur especially at the horizon. But anyway, so we've sort of covered the way to play around with the texture sampling capabilities, and I refer you to the texture animation video to look at just how to do texture. I'm assuming you know what's going on. We just have a checkerboard here. It's just very simple. It's repeated across the surface of the quad for the purposes of illustrating these aliasing issues. Moving across now to the shader. Very simple shader. Effectively a pass-through for the vertex shader. Just projects, transforms the texture coordinates appropriately using a script made available by Unity. We just multiply the texture coordinates by 10 because we want to scale the texture down and make it repeat across the surface of the quad. That's all that is. So it's very simple, and then we just sample the texture. The key thing to look at here is we're going to play around with the filtering modes, and we'll see the effects strongly in this demo. So what we have here is our script, and we're just going to play around with the scripts to see what we get if we modify some of these parameters. So first of all, we've got trilinear filtering at the moment. That's all Jim Dandy. We get a fairly high quality view. Let's take it back to point. And then go back to the demo and run it again. Oh, look at that. See how the sampling is very poor quality. As you can see, they're even close to the edge, close to the camera where the pixels are not that distorted. You get just lots of aliasing and staircasing across the edges, and then when you get to the distance, the pixels are so distorted that you get real problems getting any real quality sampling image at the horizon. So you do point sampling in your game, which is nice and cheap. You're going to get swingy terrain textures, and that's not good. Going back to the sampling mode, let's move along to the next highest quality, which is bilinear. So remember from theory that this is a bilinear interpolation surrounding 4 texel points based upon the center of the projected pixel on the texel space. And that gives us a reasonable benefit across our texels. So when we turn that off and turn that on again, so the texture starts, yeah, not bad. Yeah, it's much better than the point sampling before. And we can see here that at least the dark lines and white lines go to the distance, and there's some sort of sense of structure, but still there's a lot of blurring and detail disappears. So we want that to be crisper. So we go back to our script, and we turn on trilinear. Trilinear. Yeah. Don't you love auto completion? And turning that on in the shader. And we see again that in comparison towards the distance, we're getting a quite nice definition of the squares. At some point, they're going to merge into a very small, munged up value. But you can see it improves over the bilinear and much improved over the point. And then we can play around. Now this is a very subtle option, and in fact I don't know if it has much of an effect. You can play around with the anisotropy level. So this is the amount of distortion that the anisotropy samples along the major dimension inside the sampling. And you'll see that in the lecture notes. So we turn it back down with the trilinear and we see, oh, it's a bit blurry. Okay, maybe it's a bit more pleasant. But anyway, at the rising we see that it just munges up into nothing. There's not much crisp detail. That's because it's only got a pixel. Well, sorry, the ratio is only 1. So the pixel is effectively rotated but not distorted along an axis of anisotropy in texel space. So we go back and we push it up to 5 maybe, just to show some sort of gradient of improvement. And when my system catches up, oh, look at that. So all of a sudden, in the distance, the details are getting crisper. Why? Because the distorted pixels having an anisotropic quality to them are captured better by having a higher level of anisotropy for the driver to sample the texel space. And if we improve that, we get to some point here. We just take the maximum value. This is the C# script allows. And all of a sudden, it just gives a much more subtle effect, but you'll see that there's a slight improvement, especially at the rising, where the pixels are very strongly distorted and very anisotropic in nature. And you get a better sample. Remember, we're trying to get the integral of the function under the projected pixel in texel space. So the more we match the shape of the projected pixel in reality with our approximation, the better sample we get. A little exercise for you. Brisbane Railway Station has a checkerboard floor. Wander in there and, without embarrassing yourself in front of people, put your head down close to the floor and see, as that checkerboard floor goes into the distance, how good your eye is at anti-aliasing the sampling, because your eye is a discrete sampling system. It has rods and cones, which in a similar manner make up, has a pixelated, discrete surface. But when you look at this floor in, say, the Brisbane Railway Station, you can see for ages with very high levels of detail, mainly due to the high resolution of your retina, but also because it's got some very sophisticated processing that goes on, which makes sure that you see things in a fairly undistorted manner. Sometimes this can be defeated, but it's just a very interesting little exercise to look at a checkered floor disappearing away to you, and you can marvel at the engineering that is in your eye. Okay, thank you very much. That's the end of the video.